I'm going to go through how to do a noble gas configuration. It's usually more effective to have the electron configuration first, and then what we will do is we will go ahead and do a noble gas configuration. So let's go ahead and go with selenium, which is element number 34. We're not really worried about mass because we're dealing with the electrons. We know it's number 34. Now, if you kind of look at how it's set up on the periodic table, and you can locate where it's at, you're going to notice it's in the 4p's. So if you count it, you know it's going to end with 4p4. And you can look at your notation table that I put in your notes for Schoology. I can go ahead and do my electron configuration to get to it. V1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Move it over. Oh, we got a sequence. 3d10. And then I will look in the 4p's, and we have 4p4. That would be my electron configuration. If you add up the superscripts, it would add up to 34. It goes in sections of 10. So 10, 20, 34. Now let's say I want to do a noble gas configuration. Well, you're going to notice that on the far right, down that column, they all say P6 except for the top one. So you're going to go with what I call the highest P6. You have two choices, 2p6 and 3p6. Makes common sense that the highest P6 is going to be 3. What is the element that matches up with it? Brackets, AR. That just means that AR substitutes for all this part. We also call it shortened form. But when you do this, you need to make sure that you put in the leftovers. So it's going to be 4s2, 3d10, 4p4. I'm going to add valence electrons and dot diagrams to this. So first of all, we're going to have our SE. Now SE, we're going to look at the highest energy level for my electrons. It is only these two. 4 is a higher energy level than 3. So I'm going to look at the superscripts, and it's going to say a 2 and a 4. That is 6. So that is the number of valence electrons I have. I'm just going to put 6DE, and then I'm going to put 6 dots. So it's going to be 1, 2, 3, 4, 5, 6. And we're going to wait to kind of correlate that to what we're doing. So this would be what you're doing as far as a noble gas configuration, and also doing a dot diagram and determining your valence electrons. Let's go ahead and do another one. Now let's go ahead and do MO, molybdenum. MO, and my element is number 42. If I look at 42 and I look at my notations, you're going to see that it's in the 4Ds. And you just have to count. 41, 42, 43, 44. And also make sure you have a periodic table, or it won't make any sense whatsoever. But you can play it again too. Now I just have to do the configurations all the way over to there. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5, S2, 4, D4. And that's going to be number 42, molybdenum. And again, we go in sets of 10, 20, 30, 38, 42, which matches my atomic number. Now let's go ahead and do a noble gas configuration. Well, again, I noticed that they're the P6s. So that one is going to match up to an actual element, which is Kr, which I put in brackets. I don't put MO in brackets, it's going to be the noble gas. Again, it's a shortcut. And then I'm going to put the leftovers. 5s2, 4d4. Now let's go ahead and do the valence electrons. You're going to notice that my valence electrons are going to be off of that 5, which is my highest energy level. So I'm not going to write Kr now. I'm doing a dot diagram for this guy here, and it's going to be 2 dots. Or how many electrons did I just put here? 2 valence electrons. Let's go ahead and do another one. It's all kind of simple. You just do everything the same process, regardless of whatever element it is. So let's go ahead and do, let's do 10, which is Sn. Sn is number 50. I know if I'm looking on here, it's going to be 2p, 3p, 4p, 5p, and it's my second one in the p, so it's going to be 5p2. Then I'm going to go through and do all the stuff before that. It's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Let's make some more space. 5p2 is way out here. 4p6, 5s2, 4d10, and 5p2. If we count it in the different sections, it's 10, 20, 30, 38, 48, 50, which matches up with Sn. Now I can do my noble gas configuration. Go into my highest P6, and we're going to do the element that matches up with it, which is going to be Kr. Then I'm going to put in my leftovers. Now we know our highest energy level is going to be a 5. 4 can't be. 5's a higher one. So you got 2 separate ones. Higher level math, what is 2 plus 2 for my superscripts? That is 4. And again, I will explain why it does this, but this is what it's going to look like. And then how many valence electrons do I have? Well, I just wrote 4 dots, 4 valence electrons. So that is how you're going to do that part. Once you can do an electron configuration and a noble gas configuration, dot diagrams are your valence electrons. There will be one additional section to this.